Okay, so a rational expression is, I'm going to write the definition right here, when there is a variable on the bottom of a fraction. I'm not even going to say the word denominator, okay? Denominator, people even hear that one. They're like, oh, crap, which one's the denominator? Okay, well, the bottom is. But if there is a variable on the bottom, there will be that is a rational expression, okay? Why does this have its own unit? Like, big deal. We've done these. We've factored the whole thing. This is a whole different unit because when you have a variable on the bottom, a couple things change. The biggest thing that changes is that sometimes now there are numbers that can't play, okay? Because then they make this thing unsolvable. Now, what I mean by that is if we just look at this one equation right here, just look at that one. What value, what equation, or what equals, what thing on the bottom would be bad in x plus 7 over x plus 8? Now, first of all, it's a rational expression, right? Because there's a variable in the bottom. But there's a number that wouldn't be allowed to play here. Every number in the world could play except for this number. What is it? -8. Why on earth -8? Is that bad when the denominator is 0? Try it in your calculator. 5 divided by 0. That's it. You just go 5 divided by 0. Tell me what it equals. Error. Can't divide by 0. Why not? And this is like almost like a philosophy question. If I had 8 pizzas and I divided it by 0 people, how many pizzas would they get? Some people go, well, 8. What do you mean 8? You had 0 people. How can you divide? Like, if I have 8 pizzas and 2 people, I can, hey, they get 4 pizzas each. No, but what about the other way around? Because people go, well, it doesn't make sense the other way. Okay, if I had 0 pizzas and I divided it by 8 people, how much would each person get? That makes sense. It truly works. But if you have 8 pizzas and you divide by 0 people, it's like, I don't know how much each gets because we don't have any people. Okay? So that's why it's bad to divide by 0, because it doesn't make sense. It's undefined. So any number that makes the bottom equal 0 is called a restriction, or is called a non-permissible value. Okay? So the restriction here, or let's put non-permissible value, is, so we could say this, x cannot equal -8. If -8 gets put in there, well, -8 plus 8 is 0, I don't even care what the top equals. Now what's 0 divided by 0? Ooh. What's 0 divided by 0? Try in your calculator. 0 divided by 0, what do you get? Error. Why isn't it 1? We learned in grade 3 that if you take anything and divide it by itself, it should equal 1. So 0 divided by 0 should equal 1. But you can never divide by 0. Okay? So all you're going to do today is find out what's bad, what's not allowed. Because when you do these, you're not just going to do the factoring, you're going to do what is bad. Now, we can kind of assume, hey, if there's a variable on the bottom, there's always going to be something bad. Okay? Not always true. Look at this one. X squared plus 1. Is there a number that could be bad there? No. The reason is because whatever you square is going to be positive. The answer, right? And plus 1. You can't make that thing equal 0. How about the next one, right beside it? What would be bad here? Now, the reason I'm pointing this one out, because people can't just look at it. Like the one before it was negative 8. Negative 8 plus 8, 0. Easy. How about this one? Now, I want you to use algebra. I'm going to say 2y plus 5 cannot equal 0. That's a fair statement, because 2y plus 5 can equal 0. The bottom can equal 0. And then you just use algebra, just like you always have. Well, I'm going to minus 5. Minus 5. 2y cannot equal negative 5. Then I'm going to divide by 2. Divide by 2. Y cannot equal negative 5 over 2. So you do it just like before, except your equal sign is going to have this little slash in it. So that would be the restriction. Now remember what a restriction is, okay? Anybody that is restricted is not allowed to go. You're a non-permissible. They're the same thing. Okay? You're not permitted to come in. You are restricted from coming in. Okay? So those are kind of the synonyms in the whole rational expression unit. Now, like I was saying, if you really understood the last unit, this is going to feel like review. Okay? And I really like this unit. For the reason is, the notes are short, and the students always get their work done in class. Okay? Every single student, I can honestly say this, that was here, and some people writing tests finished their homework in class today. Okay? So maybe you want to kind of think that way this week, and maybe if you've got other stuff to bring, because it's got to be quiet in here the whole time. You're not allowed to leave early, right? You know that. But some people are working ahead on the next one, right? Because they look at a few examples, and then they start working ahead. And why would you want to work ahead? Why would I want to do more math? Well, because that even gives you a leg up tomorrow, right? This would be the perfect course if we could always finish in class. Okay? And that's what we want to kind of strive for. We're going to strive for that today for sure, but let's kind of go for that every day, right? Because you guys get way better class averages if you finish in this room than if you take it home and A, don't do it, or B, just kind of rush through it so you can actually, you know, get your 5 out of 5, and who knows if you know it for the exam, but at least I got 5 out of 5 in my homework. Now, there's some weird things that go on with these non-permissible values, because I just want you to look at, well, let's look at these two, okay? So 2x plus 2 over x squared plus 3x plus 2, and 2 over x plus 2. Now, those are kind of the same thing, except for one small thing. Now, let's factor this one, okay? Everybody's favorite word, let's factor. We're going to factor this one. Now, let's talk about the top. Can I factor the top? Can I take anything out of both of those? 2. So this would equal, shouldn't have made my circle so big here. This would equal 2 times x plus 2, right? Plus 1, thank you. I made that mistake in the last class. I think I would have caught it. Now, what would be the bottom now? Remember, I'm looking for two things that add 2, 3, and multiply to give me 2. Yep. What would it be? 1 and 2. So then, x plus 1 times x plus 2. Now, after you do this, now, since everything's multiplying by each other, maybe you're saying, but no, look at all the plus signs. But no, I'm just talking about the brackets, right? Is there anything we can cancel? Is there anything on the top and the bottom that look the same? X plus 1. So we cancel that, and this equals 2 over x plus 2. Ah. So are those two expressions? What's the difference between an expression and an equation? Anyone know? Equation has an equal sign in it, right? Expression is just like, yeah, some statement, but no equal sign. So, right there, if this was a multiple choice test, I proved that those two are the same thing. But are they the same thing? They are, except the first one, or the one that we factored, has more restrictions on it than the second one. This one here, if you just got this question, 2 over x plus 2, what's the non-permissible value? -2. This one here, okay, if you were given this and you got to here, what's the non-permissible values? -2 and -1. Now, right away, people are going, but I canceled it out. If it was ever never allowed to, or if it was never allowed to play anywhere in the question, it's never allowed to play for the whole question. So if you look at that, 2 over x plus 2, if you just look at that, then you're going to say x can't equal -2. The difference between this and this is this one had to be factored to get this. And when you factor, if there's anything that's ever bad, it stays. Okay? So for this one, I would just say x cannot equal -2. For this one, I will say x cannot equal -1 or -2. Okay? Because of this. So does everybody get the difference between those 2 over x plus 2s? They are not the same. Because one had to be factored to get that. And if at any step, so sometimes you will do 6 steps. You have to look in the bottom of all of them and see what was ever bad. And you list them. You may have 5 non-permissible values, even though in the answer it's x over x plus 2. Now you sit there and go, should only be one. -2 is bad. No, all the ones that were bad. And you're thinking, well, how do you have... Because sometimes when you have something and then you factor it, and then you do a division statement. Division is the same thing as multiplying by the reciprocal. So now the top numbers go down. So now we've got some more bad numbers. Okay? So today is all about making sure you get all the non-permissible values. So don't just look at the answer. Now on the quiz tomorrow, and on the unit exam, I will have one like this. And I will say, what are the non-permissible values? A will say -2. Okay? C or D will say -1 and -2. Okay? If I catch you on that one, then we're going to have a conversation. Because I'm going to be like, what? Seriously? You missed the basics. Okay? And on tomorrow's quiz, I'll see who misses the basics. Okay? So, it's just a rookie mistake for that one to go that x cannot equal -2. Ah, -1 as well, because look at the first step. Okay? So, what I want to do is go to the next page. No, next page. 374. Okay? So you can see how long the notes are today. Okay? But again, let's go through these. And this one says express in the simplest form. Means factor it all out. Get rid of all the garbage. And state the non-permissible values. Okay? Now, in A, we have, first of all, our numerical coefficients. So it's 12 divided by 2, or better yet, what goes into both of those? 2. So I'm going to divide 2 into both of those, and that will give me 6. Now, that's an x to the 1, right? So x to the 2 over x to the 1, when we divide, that's the same thing as subtracting exponents, right? So this will be 6x to the 1, or 6x. Now, if I just came up to you and said, hey, 6x, what are the non-permissible values? Are there any? 6x. Now, on 6x, there isn't any non-permissible. There's no x in the bottom. Okay? I'm not looking for any non-permissible values. But if I gave you 12x squared over 2x, now that does equal 6x. Except, A, the way it is now, what would have been bad here? 0. See there, x cannot equal 0, right? So the answer is 6x, and x cannot equal 0. Look at B, okay? B, you should be insulted how easy they've made this for you, okay? Now, they factored it out, so it's like they've not only given you the food, they've chewed it for you. And now they're going to regurgitate it, and it's all yours. Just like little birds. Now, what do I do now? Can I do anything? I can cancel these out, and the answer is A minus 6 over A plus 7. The non-permissible values, A cannot equal. And -1. Do we just look at the final answer? No. Because if you looked at just the final answer in this one that we did in A, you would say there is no non-permissible value. There's not an x in the bottom. Okay? No. You can have 0 up top. That is the biggest question and the biggest thing that students will mix up is they will say what makes, like you can't have 6 either. I'm like, why not? Because then you have 0 up top. Nothing wrong with a 0 up top. Okay? That's why you do a study sheet. Are you going to write that on there? Because some of you, I know, will give me non-permissible values of x cannot equal 6. I'm like, you could take 0 pizzas and divide it by 20 people. They're not going to get a lot of pizza. They're not going to be happy. But you can do it. Okay? You're not going to be the most popular guy because you invited people to your 0 pizza party. Okay? But you will understand why they're upset because they got 0 pizza. Now, what if you took your 12 pizzas and put them in a room and divided it by 0 people? You're not going to be popular or unpopular. You're just going to have some rotting pizza in a room, right? Now, let's look at C. Okay, can we factor the top of C? Well, it is what it is. How about the bottom? Are there 2 things that add to -1 and multiply to -20? So x, or no, y, sorry. Y minus 5, y plus 4. Okay? These cancel, right? What do I leave up top? A 1. What is the most common wrong answer? 0. Is anything divided by itself ever equal 0? No. Try it on that little black box with buttons on it if you don't believe me. Okay? That will leave you 1 over y minus 5. Okay? Y cannot equal 5 and negative 4. Okay, let's look at D. So D, first we'll factor the top. Okay? Now, let's see how many people are getting good at this just in their head. What do you think is add to 11? Multiply to be 28. 7 and 4. X plus 7, x plus 4. On the bottom, what's that called? No. Difference of squares. Which is x plus 7, x minus 7. Okay? Those cross out. I have x plus 4 over x minus 7. X cannot equal plus or minus 7. Okay. So I just want to talk about, on the assignment, number 1. Number 1 says determine the non-permissible values. So in other words, I just want to look at what makes the bottom ever equal 0. This one did not ask me to put in simplest form. Number 2 does. So number 2 I have to do just like the examples, but number 1's even easier. Basically, I want to know, I have to know that this cannot ever equal 0, right? That's what you're going to do with every one of them. Well, how does that help me? Because look, some people aren't good at this. 8x minus 7. Oh, crap. Oh. So you'd go like this. 8x minus 7 cannot equal 0. Say the statement. Then do the algebra. Add 7. Add 7. 8x cannot equal 7. Divide by 8. Divide by 8. X cannot equal 7 over 8. Okay? So you just actually do algebra, but you know how we always did equals? Put cannot equal 0. And then you can do it mathematically if you ever run into a... Okay, if you look at E, what's the answer? 0. Look at E, come on. It's 0. Y cannot equal 0. Bang, it's that easy. So for all of A, just look at the bottoms. Because canceling doesn't affect non-permissibles anyway. So if I do simplify the top and cancel, it's not going to help me with non-permissibles. I would get my simplified answer, but they didn't ask for it. Okay? So don't worry about going and simplifying all of number 1. Okay? So you are doing 1 to 8. Okay? Now remember, you all work at different paces. So if you get done early, the worst thing that you have to do for the rest of the class is just chill. Okay? But please be nice and quiet because I want 6s all the way down. Now, last class, even my student that really goes through things quite meticulously, they were able to finish 2 by the end of the period and, very rarely gets done in class, right? But still, if the class would have been noisy, that's 1 student I would have lost. Now to you, you're like, well, at least it wasn't me. Okay, well, sometimes it is you. And that sucks, right? So if you're done, please don't talk to your neighbor. Put in your music. Work ahead if you like. Work on other stuff, whatever.